In this video, we will look at another example of 3D trig and all sorts of various tricks that can come our way within it. And so the first thing is, same as 2D trig, what you want to do is you want to start by filling in all the missing angles and any sides that you can before you dive into the question. And so let's just read it quickly. AB represents a vertical netball pole, and there are two players positioned on either side. Okay, so that's a 90 degree there and a 90 degree there. And they're on a straight line. The third player is positioned at C, and they're all in the same horizontal plane. So this is also a 90 degree there, although visually it looks a bit weird. But here's the pole, and here's player C. And the angle of elevation from C is X, and from E is Y. And the distance from B to E is K. Be careful, it's not K this little bit here. It's the whole of BE. At any stage in complicated questions, it can be helpful just to redraw it. And I might just do this for you just as an example. So just an example, if I wanted to get out of the chaos and look at just that triangle, then I would say, okay, K is this whole line, and the angle here is Y. And so if I need to work out anything, I can take it from there. The second most important thing, so the first thing is to fill in the angles. The second thing is to work out the common line. And so in this picture, AB would be the best common line, linking all three triangles together. And so my goal, like when they asked me to work out AC, might actually be to start by working out the common line AB. And so just be aware of that, that when you feel overwhelmed and you're heading for a zero, just put your energy to work out the common line. And then thirdly, if there are 90 degree triangles, like there are quite a few, I'm going to use SOH CAH TOA. That's always much easier. And if it's not 90, I'll have to use either cos or sine rule, depending on what information I'm given. And so as I dive into the question, write down the angle ABC. ABC, it's 90. The reason is that it's a vertical pole. Show that AC is all of this. That kind of gives me a headache, and so I'm going to ignore it and just work out the common line and pretend that's my only question in life. And so I've redrawn it to make it easier. If I want AB, the common line, then because it's 90, I'm going to use tan because it's the opposite and adjacent. So tan, when I looked from Y, was my opposite over adjacent. And if I want AB by itself, I'm just going to times tan up. And there I would have AB. Now if I need AC, which is their actual question, then it's also a 90 degree triangle, and so I'm also going to look from X, and that would be my opposite, and I'm wanting AC, which is hypotenuse, that's sine. So sine, when I looked from X, was my opposite over hypotenuse. I'm wanting AC by itself, and so I'll do the rearranging here. I call it escalators. Something at the bottom goes up, and something that was at the top goes down. I'm not going to get too trigger happy and sub in this for AB yet until I've got the AC by itself. And now if I want AB, I can literally just put what I'd worked out earlier in its place. And in some ways, for the first time, I look at what they actually wanted for AC, and it's exactly what I've got. And so by just working out the common line, that made that whole step a heck of a lot easier. Then the last question, if it's further given that the angle DAC, which is kind of an angle floating in mid-air in a sense, is 2x, and AD, this line, equals AC, show the distance between DC. And so DC, I'm kind of zooming out, if you can zoom out with me, and I've got a triangle in its simplicity just looking like this. And this is DC. And so this is a classic case for wanting to dive into cos rule, because you're going to be working with side that I've just worked out. So I've got the side, these are the same, so it's side, angle, side. Therefore, cos rule. How does it look? DC squared, the opposite side squared is equal to the one side squared, AC squared, plus the other side squared. I'm just going to also call it AC because AD equals AC, just so I have less letters, minus 2 times those two sides times sine times cos of the angle in between. I'm going to just neaten this up a little bit. AC squared plus AC squared is 2 AC squareds minus 2 times AC is 2 AC squared cos 2x. It's tempting to say, oh, 2 AC squared minus 2 AC squared is gone and I'm just left with cos 2x. Don't do that. Rather take out a common factor. And so if I take out a 2 AC squared, I'm left with 1 minus cos 2x. To let you into my mind, what's buzzing through my mind is that I've got a double angle. So I include that section into this question. How do I know which option is best for me? Because there's a 1 here, I'm going to try choose the option that cancels the 1. And so for me, that would be in brackets 1 minus 2 sine squared x. And that will then cancel that. And in my next step, I will just be left with 2 sine squared x. Let's get back to what's happening with the 2 AC squared. It's 2 AC squared. And if I fill in that, it's 2, and AC was what we had worked out up here, and so it's AC squared. So that would be k squared tan squared y over the bottom squared sine squared x. The sine x and the sine x squared will cancel, and so I'm just left with 4k squared tan squared y, and that's all equal to DC squared, and I'm trying to just work out DC, so I'm going to just do it across here. If I square root everything, then I'm just left with 2, a k, and a tan y, and that is what they had asked me to try work out in the question. And so there's a lot to think about in this question, lots of good juicy stuff. I hope that you found it useful. If you did, please like this video, subscribe to our channel, and share it with your friends.